We are seeing the first glimpse of science from the James Webb Space Telescope.
Using EMR and other NASA equipment like telescopes, we can look for invisible objects. The James Webb Space Telescope, for example, allows for sharper images of the cosmos than ever before. The James Webb Telescope has started to provide results after decades of construction and several setbacks along the way. In 1995, the Hubble Space Telescope amazed the globe with a view of the cosmos named Pillars of Creation. But now, Hubble's replacement, the James Webb Space Telescope, has used its infrared vision to peer through the same columns and examine the infants still resting in their dusty cots. In this video, we will be talking about the images of Pillars of Creation taken by James Webb. What do we know about the structure of Pillars of Creation? What can James Webb see that Hubble can't? How did the pictures captured by James Webb help? On October 19th, NASA announced the release of near-infrared photos of the Pillars of Creation captured by James Webb. NASA, the European Space Agency, and the Canadian Space Agency all worked together to run James Webb. In 1995, the Hubble Space Telescope took a picture of the Pillars of Creation that quickly became iconic. These three towers of dust and gas look like rock structures, but they are actually more porous than they appear. The Eagle Nebula, or Messier 16, contains the Pillars of Creation. The Eagle Nebula, found in Serpens, 6,500 light-years from Earth, and first found in 1745. When the Hubble Space Telescope returned to the Eagle Nebula in April 2015 to celebrate its 25th anniversary in orbit, it captured an even sharper image of the Pillars of Creation than it had the first time around in 1995. The pillars are located in a star-forming zone, and NASA says that the wavy lines seen at the pillars' borders, which resemble lava flows, are really ejections from stars still in the process of developing within the dust and gas. These thick pillars are the result of a collision between a young star's supersonic jets and a cloud of material. NASA said that the pillars look like desert buttes. Simply said, they are extremely thick clouds of molecular hydrogen dust and gas that have managed to last longer than their surroundings despite being bombarded by ultraviolet light from nearby bright young stars. Photoevaporation is the transformation of substances when they are exposed to high-energy radiation, such as ultraviolet light. The pillars slowly dissolve due to this phenomena, revealing tiny globules of much denser gas. Gaseous globules that evaporate are what they are named, EGGs. As a result of being cut off from the greater reservoir of gas from which they are drawing mass, embryonic stars that originate inside some EGGs abruptly stop expanding when they are uncovered. The EGGs are where the stars are born. Astronomers have high hopes that the cosmos can be uncovered with the help of the James Webb Space Telescope, the most powerful observatory ever built. Webb has an expected lifespan of 20 years, during which time it will transmit a wealth of spectroscopic and imaging data on anything from distant stars and early galaxies to exoplanets and asteroids. You may be curious about the Webb Telescope's transmission method, though, given the great distance over which it operates. Webb, for the uninitiated, is located at the second Lagrange point, some 15 Log kilometers from Earth. Data from the telescope takes roughly 5 seconds to travel to Earth, where it is then relayed to the mission control centers, according to NASA. Let's see how those mission organizations respond to the photographs. The Deep Space Network is crucial for scientists to collect from various interplanetary mission spacecraft. The Deep Space Network, or DSN, is a global network comprising 3 enormous radio antennas located on different continents. It is the most sensitive scientific telecommunications system on the planet. Barstow, California has the first DSN facility, Madrid, Spain has the second, and Canberra, Australia has the third. The reason for choosing these sites is because they enable the DSN facilities to stay in constant contact with spacecraft as our globe rotates. When a spacecraft drops below the horizon of one DSN facility, another may pick up the signals and continue contact. The signals from the spacecraft are captured by the 3 antennas and sent to the mission centers. According to NASA, these facilities are all situated equally away from one another, or around 120 degrees in longitude. Scientists use the DSN for radar and radio astronomy investigations to learn more about the solar system and the cosmos beyond it, in addition to supporting interplanetary missions and being the best at long-distance communication. But in addition to those headed towards the moon, the DSN is also used to make contact with a handful of spacecraft orbiting the Earth. NASA researchers are currently in contact with the Capstone CubeSat via the DSN as it travels to the moon. The newly generated stars are another discernible element that was not as well noticed in the Hubble telescope photos. Bright red spheres with diffraction spikes were seen floating outside the dusty pillars by Webb's near-infrared camera. The image depicts mass-forming knots inside of pillars of dust and gas. The knot gradually heats up and eventually comes together to generate new stars after reaching a suitable mass, collapsing under its own weight in the process. You might spot wavy lines that resemble lava if you look closely at the borders of the pillars. No, there isn't any lava in space. Instead, they are the leftovers from stars that are still forming in the dust and gas. It is thought that the youngest stars in the image are a few 100,000 years old. On rare occasions, they eject supersonic jets that collide with material clouds, including the thick pillars. Similar to the wave-like patterns you'd observe from a boat going across the water, the collision results in bow shocks. The energetic hydrogen molecules from the jet and shocks give these ejections their scarlet color. The Webb Telescope may see through the clouds and into the cosmos further than the pillars thanks to their near-infrared lights. While no galaxies were visible, NASA astronomers did spot a mixture of translucent gas and dust known as the interstellar medium in the Milky Way galaxy's densest region. Other than the James Webb and Hubble, the following cameras were used to take photos of the pillars of creation. Herschel's image. Far infrared wavelengths were used by Herschel Space Observatory to take pictures of the pillars of creation in 2010. This image enables researchers to peer at the pillars internally and other structures in the area and gain a deeper analysis of the constructive and destructive forces that operate inside the Eagle Nebula. Revisits. Astronomers put together a larger and higher resolution picture of the pillars of creation to celebrate the 25th anniversary of the Hubble Space Telescope's launch, which was unveiled in January 2015. Wide Field Camera 3, which was added to the Hubble Space Telescope in 2009, captured the image in visible light. Infrared photography was also done. The image has a larger field of vision and more of the hazy column's bases are visible. Although it looks like near-infrared light has enabled the most powerful telescope to pierce through the clouds to show huge cosmic distances beyond the pillars, there are no galaxies in the image. The interstellar medium, a mixture of transparent gas and dust in the densest region of the Milky Way galaxy's disk, hides Earth's perspective of the deeper universe, which is why galaxies cannot be seen in the image. NASA, the Canadian Space Agency, and the European Space Agency are working together on the Webb Telescope to the tune of $10 billion. It was sent into space on a European Ariane 5 rocket last Christmas, and it is now orbiting the Sun, 1 million miles from Earth. Despite the fact that the Hubble is still active and making theories from its position roughly 340 miles above the globe, the first Webb photos were beamed back to Earth in July. The data is picked by ground-based antennas. Hubble has been in operation into the late 2020s, far beyond its original lifespan estimate of 15 years. It was launched in 1990. Thank you for watching. Provide us with your valuable feedback if you enjoyed the video. Also, take a minute and subscribe to our channel. Stay tuned.